Who are we? Hyperledger is a part of the Linux Foundation, and for those of you who don't know what Linux is, I can't help you at all. But we have, there for the last 15 years, there's been a non-profit organization that is sat at the heart of the Linux ecosystem, doing two important things. One, employing Linus Torvalds, giving him a place to rest his head, and not have to get employed by somebody like a Microsoft or Google. But secondly, and I think perhaps more importantly, coordinating kind of the developer community around the Linux operating system and the vendor community as well, trying to make sure that when developers show up and have a bug, have a fix for that bug, that's not something they want to add to it, and that there's like an efficient way to get that in and to help grow this as a multi kind of stakeholder kind of developer community. In fact, every day in the Linux kernel, there's still 10,000 new lines of code added, 2,500 removed, and 2,100 modified. For a 26-year-old project, that's kind of awesome. But a couple of years ago, there was this recognition that that model of getting the companies together and getting developers together could be applied to other related technology domains. So the JavaScript Foundation, for example, is the home for about 20 different JavaScript UI frameworks that many of you probably use. The Node.js Foundation is also hosted there, as well as the Cloud Native Compute Foundation, which manages the Kubernetes project and a bunch of others. And a few years ago, a group of people said, maybe there's something to this cryptocurrency and blockchain thing, but where things kind of settled on was this notion that the currency side of it, the Bitcoin Foundation was handling, it seemed, the Ethereum Foundation. Is there something more to this that could be used for other types of applications? And so that's where folks decided to focus. You've already heard a little bit, and I'm sure in other presentations and other days, you've heard kind of the blockchain 101, what is it, right? To try to describe it a little more abstractly, more concretely, I tend to tell people it's two things. It's a distributed ledger, which is a way of getting a community of participants, like those of us in this room, to agree on a set of things that have happened, on a history. It could be facts, it could be transactions between us, but something that all of us in this room can use math to verify we all have the same copy of it, right? The second thing is smart contracts, things that we can automate on top of that to make this really, make it so that we can embody commitments to each other, promises to each other, processes that if three things happen, then record a fourth thing in the ledger, right? In a way that can't be clawed back or changed. And this turns out to be pretty useful. This turns out to be a lot more than just a distributed database, which is sometimes it gets called, right? It turns out to be this new kind of hybrid of a network and a database that solves some thorny coordination problems in a whole lot of different sectors. From finance, where everything they do is about having a ledger and having to reconcile these ledgers, is why it takes 3 days to send a bank wire from one bank to another across a border, to in supply chains, keeping track of how things flow, to healthcare, and I'll give some more examples just specifically of these. And most importantly, cryptocurrencies are an application of blockchain technology. Knowing how, knowing that a Bitcoin, 1.1 Bitcoins were spent from one person to another, and then that person can then spend that forward. That is data maintained in this ledger, in this distributed ledger, right? And it keeps that person from being able to spend the same token twice, right? And it maintains the system of account. But there's lots of other uses. So the one you've probably heard some folks talk about is the diamond supply chain. In 2003, there was a lot of political pressure, well, leading up to that point, a lot of political pressure on the diamond industry to stamp conflict diamonds out of the supply chain. Diamonds coming from the Congo, diamonds that were used to purchase weapons, diamonds that involve slave labor. And so in 2003, that industry came up with something called the Kimberley process, which was a way to keep those diamonds out of circulation by basically requiring everybody to file paperwork every time a diamond was pulled out of the ground or it was handed off from one party to another in the chain, all the way from the mine to the retail sector. And like every paperwork-based process, it worked smashingly. No, it didn't. It basically, you get this piece of paper at the end that has these stamps on it, like a physical certificate that accompanied that diamond, that described that diamond. But unless you could look really closely and verify that it was the right kind of stamp, unless, oh, and by the way, copies of this were faxed to some central organization in Brussels or Antwerp or something, where, you know, they kept the original, they kept the actual data that you would need in case you lost the certificate or had some question about its authenticity, but it wasn't a very transparent process. And so this industry has, for the last 2 years, been in the progress of migrating to use a distributed ledger, in which basically all the participants in that economic system, or a subset of them, have a node on a shared network. They publish every time a diamond changes hands. The sender says, I'm sending it, here's its characteristics. The receiver says, here's what I've got and its characteristics. There are other companies starting to introduce like micro embedding of serial numbers and things into diamonds to make it even easier to make sure that what was sent and what was received was the same diamond. This is now in production. There are millions of diamonds now being traced by this. And last year in late pilot mode, it caught a couple $1 million of diamonds that were being put through the system and attempted to be substituted for smaller diamonds. And that was a way that, you know, basically it's working, which is awesome, right? Eventually this turns into a titling system for diamonds, which means I might be able to sell one of you a share of a diamond that I bought and have that traced in the ledger, which is kind of cool. Other folks are working on land titles and real estate. This might sound like really boring, and the way that we tend to deal with like changing hands when we buy and sell property is kind of like very paperwork driven. Who here has bought a house or property, or like all of the forms you have to sign, and then you still have to pay 1% for title insurance, which is basically insurance that guarantees all the paperwork is there, that is supposed to be there. It's kind of crazy. But it's even worse in developing countries where they don't have a lot of trust in government bookkeeping processes, in title offices, where it is not uncommon for a politician's son to end up with beachfront property just south of the capital that they, let's just say, didn't acquire lawfully, right? Or to be selling off oil leases to properties that people didn't own, that sort of thing. So there's quite a few countries now, and here in the States actually, Chicago and Delaware working on projects to implement land title systems as a distributed ledger, where again, the participants in that network are everybody who plays a role in that, real estate agents, title offices, lenders, that sort of thing. There's folks who are optimistic that if we get this stuff implemented, we might prevent the next mortgage crisis, which for those of you who saw the movie The Big Short, you might remember that like what did the damage wasn't the irrational exuberance of all these things being bid up and all these weird derivatives, but the unwinding of those and not knowing who owned what. And so some real hope there that we could use this. I know I'm going really quickly through these examples. It's because I want to get to some real questions for you as designers at the end, and I think it'll pay off. Another big use case is around distributed identity. So identity is broken on the internet. Sorry, but I don't want to pay my taxes with login with Facebook, login with Twitter, right? I don't think many of you do either. I'd like to be able to get to a digital passport. I'd like to be able to open a bank account without taking a photo of my driver's license and sending that somewhere. How many of you have done that? Like, how crazy is like taking a photo of a driver's license? A lot of what's broken about it is we've built systems that have tended to be centralized and treat users as entries, as rows in a database, right? And there have been people working for 10, 15 years on an inversion of that model that is more human-centric, that is what's called self-sovereign ID, where your identity and the certificates that you get from other parties attesting to who you are, things like a passport, things like a diploma, things like these, are maintained in the wallet. And what blockchain brings to this, what a distributed ledger brings, is this missing piece, which is an ability to track the integrity of those documents, right? We could always use digital signatures, but we never had a really good way to distribute the keys that that corresponded to these kinds of institutions, right? And furthermore, tracking who I shared that data with, and then revoking access to that when, say, I'm seeing a doctor on vacation, I share patient records of mine with him, and then I am no longer on vacation, I don't want that doctor to still have copies of those records, right? So this is a way to deal with a lot of real thorny issues around the personal data kind of world. Again, there's multiple different presentations to give around this to really explain it in detail. This is something getting a lot of people excited right now, and is in production today in a couple of different places with governments looking at it. It's pretty exciting. But what all of these examples have done is trigger a lot of debate out there, especially since it's a very different world being described than what folks who work on cryptocurrencies envision. And so I want to try to lay out a landscape and a mental model for describing this, because I really need the help of designers in this community in helping make this understandable and clear to the rest of the world. So what we really have going on here are two different ways of talking about permissioning on these distributed ledgers. Because we have the fully public facing, fully world readable, and fully world writable ledgers that you have in the cryptocurrency world, where participants are anonymous, they need no permission to join. And you might also have fully private read and fully private writable permission ledgers that are about connecting 10 banks or 30 banks together, right? And you have some gray area in between. There are public-facing permissioned networks out there now. The Sovereign Foundation, which is one of the participants in the Self-Sovereign ID projects, runs a public-facing permission ledger around digital identity. That's also how some of the land title projects and education projects are being designed. You might have permissionless private networks. I'm not quite sure the model. I kind of threw up public polls as an example, where you want a lot of people to be able to write, but only a few people to be able to read. But these two dimensions cause a lot of controversy out there, right? And for good reason, because I think the concept of cryptocurrencies as this liberating kind of thing, not having to ask permission from people, is really exciting. But let's talk about a use case where I think as citizens, as humans, we would start to think differently about permission, right? So there are quite a few people looking at deploying distributed ledger technologies as a way to enable the sharing of medical records. And all sorts of medical records, x-rays, prescriptions, histories of your treatments of care. And there are active projects now by folks like Change Healthcare, by Aetna, by a whole bunch of startups to really dive in and do this. I flew here from Las Vegas, where the HIMSS conference was happening, and it seems like almost every large health IT company is trying to figure this out. And in this case, you don't store the raw healthcare data on a permission ledger. I'm sorry, on any kind of distributed ledger, because these things are designed to be immutable. These things are designed to be uncensorable and designed to be shared everywhere. But you do store signatures and hashes and enough information to prove the integrity of this data. You know, if I want to show a new doctor my prescription history, and they want to see, okay, your old doctor wrote prescriptions for these pain meds, I think they want to know I haven't added a zero to the dosage or numbers of pills, right? They want to know it came from a legit doctor, right? So in this scenario, there's a lot of really sensitive data not being stored in the ledger, but being tracked by the ledger and whose signatures are in the ledger. And that's kind of a sensitive type of scenario. But we have cryptography. We could encrypt all day long. In theory, we could keep it all private. But what happens when that fails, right? So as software developers, we tend to assume the best of intentions by our users. We tend to design for when things work. It's a good thing most of us don't work on avionics software or design planes or cars, but some of us are starting to. And when we put real assets into these kinds of systems, real personal data into these systems, we need to start anticipating for failure, right? So in the healthcare setting, even if we use all this great cryptography to guarantee that people's personal health data is never in a distributed ledger, even if it's only shared with a number of other hospitals and clinics and that sort of thing, what happens if we make a mistake? And if we accidentally reveal, even metadata matters, right? Revealing that a certain person has had an HIV test result, even if it's not what that result is, but at a certain time or a certain place, is sensitive data, right? And all software has bugs, right? All software, at some point, you hit a failure like this. But in a distributed ledger, in these kinds of systems, one of the key properties is we can't delete something from it. We want to make it hard to be able to delete something because we want to have this same body of fact between all of the participants. So how do we claw back from that failure? Well, there's no smart contract in the world that, thankfully, I mean, there's no magic DRM system in blockchain technology, right, that could do what iTunes tried and failed to do, right? There's no way to claw back and tell somebody to forget something that they've been told. right? I can't, just as I can't tell you in this room to forget that, about this presentation or the words that I say or anything like that. You have the freedom to walk out of this room and remember that fact. Therefore, whenever we're talking about personal data, and I think whenever we're talking about almost any meaningful use of blockchain technology, we're going to need to talk about governance. We're going to need to talk about how the participants in that marketplace who are processing that data, what are the human agreements that they have between them about the types of data they'll respect and what steps they take when things go wrong. So we have plenty of examples of these kinds of agreements out there, right? Some of them are regulations. So in the healthcare setting, there's something called HIPAA, which says, healthcare data that providers have, that doctors have, that clinics get, can only be shared with other doctors and clinics and what they call covered entities. It has to be encrypted at rest, encrypted in transit, all that kind of thing. And it can only be about the treatment of care. And it's probably why, you've probably received spam or seen ads on websites based on, non-healthcare data that people know about you, like your salary or where you live or that sort of thing. But hopefully you haven't received a whole lot of spam or targeted advertising about your medical conditions, right? That stuff is considered much more sensitive and has more successfully been kept from being breached. Likewise, in the European Union, there's a new set of rules that will come into enforcement in May called the General Data Protection Regulations, or the GDPR. How many of you know what that is or heard of it? This is like the peasants with pitchforks storming the Bastille moment in privacy from people saying we're fed up with the presumption that technology companies have that when they give you their data, it's your data that you can then copy and share and resell endlessly, right? It stipulates that consumers have this kind of inherent right to that data and can claw it back when they want. In the diamond example, I mentioned the Kimberley process. This is something that they worked out politically and said in order to stop conflict diamonds, we have to share more data internally. In fishing, there's something called the Nauru Agreement. In fact, there's agreements for every species of fish out there. And quotas that say, which countries are allowed to catch which fish, where, and when. All these kinds of agreements out there that form the bedrock for how so much of the world works. But even the permissionless world has these kinds of governance structures, whether they admit to it or not. In the Ethereum community, how many people heard about the DAO hack or know what that is? Okay, great. And so you recall that was a scenario where a mistake was made, where that opened the door to what was at the time $150 million worth of Ethereum tokens, which I don't know what that would be worth now, but a couple billion or so, was vulnerable to be stolen by nefarious actors. There are a bunch of white hats who came in and stole it and refunded people. But what ultimately happened was that network made a decision between the developers and miners to reverse that transaction, right? To bail out the people who had bought into this broken smart contract. It was a decision that they decided not to make when there was a second hack later last year called the Parity Wallet hack, where about 300 million in net was lost, and the same debate happened, and that community decided not to take the risk of such a fork, such a hard fork, to go and clean that up. Likewise, in Bitcoin, you have debates over architecture and vicious debates because there's different interests out there, different winners and losers when these kinds of changes are made. And in control in these scenarios are the developers and the miners working on these systems, right? And there's always this right to fork. There's always this right for the participants in each of these ecosystems to say, okay, I agree with a bunch of dissidents, and all of us are going to bring our compute resources and our coins and other things and go in a different direction. And that's why we have Ethereum Classic and Bitcoin Cash and a lot of these derivatives in that space. And it's a useful tool to keep tyrants in check, right? Just like in open source software. The right to fork means if Linus Torvalds ever fails to be a good software leader, right, people can take his code in the kernel and go in a different direction, legally with full rights. They might want to call it something different, but that's possible. And the fact that they haven't is a testament to him and probably the Linux Foundation being able to manage that. So I want to encourage people to start to think, rather than thinking about in terms of centralized versus decentralized as this binary kind of thing, to start thinking about governance structures for blockchain technology systems, and thinking about minimum viable centralization. I know I'm reusing the MVC term, and maybe it can be convinced to call it minimum viable governance or something like that. But I think if we found ways to talk about and recognize governance in these blockchain systems and reduce the role of a central actor, somebody who, in all of these other business settings, for example, kind of defines who's in the diamond market, right? Who shows up with a node and can connect that node and start exchanging data. Or in that healthcare setting, who is a covered entity and agrees to this human governance of when a mistake is made, clawing back that data, or agreeing to ignore it when it's written in that data, in the ledger, right? And the best kind of minimum viably centralized organization is going to be a very lightweight consortium that sets a few clear criteria for when new nodes can join the network, and can automate wherever possible this on-chain governance that enforces these rules, looks for bad behavior, but occasionally flags a bad actor and says they need to be removed or fined or something like that. And I'll submit that we have an example of this out there in the real world today, for all of its warts, for all of its mistakes, which is the domain name system and ICANN. And ICANN, for those of you who perhaps don't know, is the organization that certifies domain name registrars. So when you go and register a domain name with GoDaddy or Google's DNS service or others, they're the ones who say, here are the rules that the domain name registrars have to follow. You have to allow people to move their domain names from one registrar to another. And if somebody is abusing a trademark, if I succeeded in registering Walmart.com with a 1 rather than an L, right, and I set up a website that looks like Walmart's website, well, I should expect not only an issue to pop up, but there's a set of rules to follow for deciding when I have to surrender that domain name to the trademark owner. Sometimes that feels unfair, sometimes it feels arbitrary. Somebody might say, shouldn't we just all vote on whether, a dispute like that goes one way or the other? The fact is, I kind of like knowing that there are humans in the loop there, evaluating these scenarios, and sometimes making subjective decisions, but let's see how we can ride that balance between subjective and objective, right? And if we found ways to bring more governance to more of these ledgers that look like ICANN, I think we do a lot to address kind of the skepticism and concern that people have about how trustworthy are both the unpermissioned networks, that we could build things on top of Ethereum and Bitcoin, as well as these permission networks, right? How do we keep them? So here's some questions I wanted to pose to you all as designers. This is because, a lot of the people working on this are back-end server nerds. Like, a lot of us are thinking hard about how do we build these systems that don't require, a big giant company at the center to enable a really healthy ecosystem. Don't require a central kind of client server kind of thing. But there's a bootstrap problem, right? This is not like setting up a website or building an app where it solves a problem for just one company. You kind of have to launch this for enough of the participants in the diamond industry for this to be useful, right? And doing that conceptually, it involves a lot of these kinds of presentations like I'm giving here, but to actually manifest that into an application and make that run. At Hyperledger, we've got a lot of the back-end code, and I could tell you much more about kind of what we're doing as an open source project. But what we don't have yet are a lot of great front-end code that makes that an obvious and easy thing to pick up. We've got some tooling. We've got something called Composer that makes building these apps easier. But I think helping developers understand and businesses understand how to launch these things and how to stand up like a minimum viable network of 3 or 4 nodes easily is something we could really use help with. How do we make the governance processes clear in the design, right? I've shown a lot of, frankly, kind of nonsense pictures of things with lines between them, right? I'm being cruel to myself, perhaps, but how do we actually create meaningful charts like that help explain how these governance systems work and what the balance of power is and how decisions are made and that sort of thing? And how can we help the participants in these networks, the businesses, the citizens, if we're talking about government services like land titles, consumers, I hate that word, by the way, that's why I always use it in quotes. People are producing as much as they're consuming, right? But for lack of a better word, consumers. Regulators, how do we make them feel meaningfully empowered on these networks, right? How do we help a patient managing their healthcare records know that they could pick those records up and go and take them somewhere else, right? A lot of people have talked about wallets and worked on wallets. I think wallets are to this world what the web browser was to the web. We may need to talk about kind of a unified wallet, just like having a web browser per website would have been done back then. And that's a place where understanding how to convey that sense of agency and that sense of control to individuals is not something I think we've done very well in software, just in general. And then finally, how do we, as we're reinventing many of these systems, how do we, as we're building these things out for the existing industries, how do we reinvent them meaningfully and not just pave the cow paths in terms of hardening a bureaucratic process that might exist today? So this page was just kind of inspired by listening to the earlier talks. There's tons of other hard challenges in the blockchain space from a design perspective and a usability perspective. If my slides aren't evidence of that enough, I would love to talk more with each of you. We also, as an open source project at Hyperledger, have a lot of ways for people to get involved who are not the back-end coder nerds, right? Who want to help both make what we're doing more apparent to individuals, to bootstrap templates, to bootstrap kind of UI ideas. We would love folks to get involved. It's an open source community, and I'd be happy to answer more questions about that. But with that, that's kind of all I really prepped. Any thoughts or questions? In the back.
When are you guys going to do an update or follow-up to the experts that
That's a great question. So at the end of October, we put up a course called Blockchain for Business, which was on edX, which is the main MOOC used by Stanford and Harvard and MIT. And it had 75,000 people register for it, and a couple thousand finished it already. And so we're working now on follow-ups specifically for some of our projects like Fabric and Sawtooth. And we're hoping to now turn those into open source projects as well. We kind of paid for the first one to get made, so it would be done. But we have an education and training working group as well. So, and this is all open content. So those of you who do training, those of you who find yourself giving like a 3-hour intro course somewhere on like how to build these apps, we'd love to have you take this content and use it in your own courses, but also participate in the creation of more. So thanks for the question. Others. Yes?
We're going to have to talk louder. Yeah, go ahead.
I can repeat your question too.
So, what's been the biggest barrier or source of friction in convincing participants in the network to switch over from what you're using now to decentralized?
What's been the biggest barrier in convincing participants in these communities to switch over from some old way that they're doing things to using these technologies? First, for a while, it was the lack of these technologies being in production release. So we have Fabric hit a 1.0 last year, and a 1.1 release candidate is out. Sawtooth hit a 1.0, and those are being used in a couple of dozen different production systems now. So that excuse has kind of been taken away, although I think there's still that perception, which is valid, that these are young technologies. And so many of these use cases end up being very core, right? It was easy to convince somebody to launch a blog, all right, in the early days of the web, because that was very peripheral to their core business. This is about managing a set of assets, right, and kind of core. So I think a bigger obstacle is no one necessarily wants to be first in many of these cases. Some folks need to be nudged or cajoled into doing it a bit. So I'm finding I don't have to really convince people anymore that they need to take a look at doing these kinds of things, because they're starting to realize places where they have real problems today that these kinds of things can solve. In fact, about half the time I find myself saying you don't need a blockchain for that, right? You don't have the trust issues in a centralized, that suggests that it's, because any example I could give you where you could use these things, you could come back and say, couldn't you just provision a couple of big AWS instances and use a really super efficient serverless architecture and just have people reading and writing all day long and scale to 10,000 transactions a second and infinite read? And yeah, the answer will be yes, you could always do that. The problem is it puts the company or the organization or the individuals at the center who manage those servers in this like power position that so many industries just don't want and can't tolerate. So doing this is harder, and convincing people it's worth the learning curve, both at a technical level and at a business level, to adopt that is a challenge still. So the more that we can find examples and real companies doing this and talk about that using our tech, the better.